All right, so when you look at these, again, with these, this first problem has two terms. What common factors can you remove from those two terms? A 5 and an x squared, and what's left is going to have the exact same form. Okay, so when you look to see what's left, to determine what's left, you're going to take your original form and divide by whatever you factored out. So 15x to the fourth divided by 5x squared leaves what factors? 3 and an x squared. And then for the second term, again, when we remove a 5 and an x squared, we're left with just a 5. And so that's your set of factors. In problem B, again, here we have these three terms. What common factors are contained in all three of those terms? An a and an x. And so again, the way that I always present this is whatever's left inside these grouping symbols has to have the same form as the original problem. One group minus another group plus another. And so what's left when we remove an a and an x from this first group? We're left with a b and how many x's? We had 3, we remove 1. In the second group, we're left with the number 2 and how many x's? Just 1. And finally, in the last group, we're left with a 3, a b, and that's it. Okay? There's nothing else that can be factored from this, and so you're done. Okay, now, the last problem here is more similar to the problems that are going to get complicated later on. This one has just two simple factors, but it's the same process. We have two groups of factors. Are there any factors common to both of those groups? Now, instead of it being a monomial factor, this is a binomial factor, x plus 1, that's common to both. And what's going to be left in the grouping symbols is exact same form as what it started with. One group minus another. So when we divide out or factor out an x plus 1, what's left in our first group? 8x, and what's left in the second group? The minus 3. So again, doing it this way helps set up the and be consistent with the process that you'll use when you get a little more complicated type expressions.